Hi everyone, this is Dr. Siva Nageswara Rao, working as Assistant Professor of Mathematics in the Department of Mathematics and Management Science. In the previous lecture, we studied about maxima and minima of a function involving two variables. Now in this lecture, we will see about our aim is to find the extreme values of the given function subject to the given condition. In previous lecture, we never see any condition associated with the given function. We have a function involving two independent variables. Based on the procedure, we found critical points. We found d value by using second order partial derivatives. Based on the conditions, we decided whether the function will have minimum value or maximum value or neither maxima nor minima. Now, in this lecture, we will see the extreme values of the given, we will see how to find extreme values of the given function by using the given constraint. By using the method, Lagrange's method of undetermined multipliers. Now, what is Lagrange's method? Our aim is to find minimum or maximum, sometimes and maximum values of the given function f of x comma y subject to the condition g of x comma y is equal to 0. Here this one is very important. Based on the given condition only, we are able to find out the extreme values of the given function. First of all, we will define the Lagrangian function. What is Lagrangian function? L of x comma y comma lambda is equal to f of x comma y, this is expression, minus lambda multiplied by g of x comma y, and g of x comma y is a constraint, condition. Now, if you want to find the critical points or stationary point, what is the necessary condition? The necessary condition is dou L by dou x value should be equal to 0, dou L by dou y value is equal to 0. Means, for this equation, here we will apply partial derivative with respect to x. You will get dou L by dou x. Similarly, partial derivative with respect to y. You will get dou L by dou y, equating to 0. Here, we will solve these two equations with the help of g of x comma y is equal to 0. We will solve these two equations with the help of g of x comma y is equal to 0. Here lambda is called Lagrangian multiplier. Lagrangian multiplier. Now what are the steps to be followed if you are calculating either minima or maximum values of the given function by using Lagrange's method of undetermined multipliers? What is step number 1? Construct the Lagrangian function. What is Lagrangian function? L of x comma y comma lambda is equal to f of x comma y minus lambda multiplied by g of x comma y. F of x comma y is given function, g of x comma y is constraint. Now immediately calculate its partial derivative with respect to x as well as with respect to y. That is, you will get Lx comma Ly. Now solve resulting system of equations with the help of g of x comma y, g of x comma y is equal to 0. Finally, you will get the stationary points. We will substitute these stationary points into the given function. Based on that, we can able to identify whether this value is either minimum or a maximum. Now here, one thing you need to remember, this technique is useful when the extreme must occur on the curve or on the surface rather than on the open region. This is what you need to remember. Next we will see one example. Find minimum value of the given function subject to the condition x plus y plus z is equal to 9. First of all, we will write the Lagrangian equation, the Lagrangian function. So lambda of, L of x comma y comma z comma lambda is equal to function x square plus y square plus z square minus lambda multiplied by x plus y plus z minus 9. Calculate. Here see, previously in the procedure, only two independent variables are there. So we are calculating Lx and Ly. But here the function involving three independent variables, x, y, z. So we will apply partial derivative to L with respect to x, y, z. Then what is dou L by dou x? 2x minus lambda is equal to 0. Dou L by dou y, 2y minus lambda is equal to 0. Dou L by dou z, 2z minus lambda is equal to 0. From these three equations, make x, y, z as subject. You will get x is equal to lambda by 2, y is equal to lambda by 2, z is equal to lambda by 2. Previously what I said, we will solve these partial derivatives with the help of g of x comma y. So anyway we have x, y, z value. We will substitute these x, y, z values into x plus y plus z is equal to 9. By substituting these values into x plus y plus z is equal to 9, you will get lambda is equal to 6. If you know lambda, then we know very well x is equal to lambda by 2, y is equal to lambda by 2, z is equal to lambda by 2. By substituting lambda is equal to 6 into three equations, you will have x is equal to 3, y is equal to 3, z is equal to 3. Therefore, what is the stationary point? 3 comma 3 comma 3. Now our aim is to find minimum value. So we will substitute these points x place in place of x with 3, y with 3, z with 3 into the given function. You will have the value 27. What is f of x comma y comma z? X square plus y square plus z square. So 3 square plus 3 square plus 3 square, which gives 27. So this is the minimum value for the given function. Next we will see one more example. A rectangular box open at the top is to have a volume of 32 cubic feet. Find the dimensions that minimize surface area. Here our aim is to find the dimensions of the box, means length, breadth and height. Our aim is to find the minimum values of x, y, z such that the volume of the rectangular box is equal to 32 cubic feet. Now the solution, assume that x be the length, y be the breadth and z be the height of the rectangular box. What is given? The rectangular box top is open. If you are observing like a matchbox, this looks like a rectangular box. Top is open. Assume that all the sides are closed. Then what is the surface area? Here rectangular box means three-dimensional. So you can see a plane which lies on xy, a plane which is parallel to xy, a plane which lies on yz, a plane which is parallel to yz, a plane which lies on xz and a plane which is parallel to xz. So you will have 6 different faces. If you are taking area of each face, it looks like a rectangle. Therefore area is length into breadth. So if you are taking all 6 faces, the surface area is 2xy plus 2yz plus 2zx. This is the total surface area. But what is given? Top is open. So I will assume a plane which is parallel to xy is open. Hence, what is the surface area? Then this will becomes 1. So the surface area of the rectangular box is xy plus 2xz plus 2yz. And also what is given? Volume is given. Volume means length multiplied by breadth multiplied by height is equal to 32 cubic feet. So we have one function involving 3 independent variables and one equation involving 3 independent variables. So I will denote this with g of x, y, z and this one as f of x comma y comma z, and this is equation and this one is expression. Now our aim is to construct Lagrangian function. What is Lagrangian function? L of x comma y comma z comma lambda is equal to f of x comma y comma z minus lambda multiplied by g of x comma y. Now we will apply partial derivative to this Lagrangian function with respect to x, with respect to y, and with respect to z. You will get three equations. Again, like previous problem, we will make subject as lambda by using first and second equations. By using first and second equations. Now, from first equation make subject as lambda, second equation make subject as lambda. What is your observation? Clearly, LHS is same. LHS is same. So we will equate RHS. By equating RHS, simplify this expression, you will have y is equal to x. By using this y is equal to x, previously we have three equations. Now take third equation. Substitute y is equal to x into third equation. Substitute y is equal to x into third equation. Then what you will get? You will get lambda is equal to 4 by x. Lambda is equal to 4 by x. Now substitute y is equal to x into first equation. That is, previously we have this. Now substitute here. Then you will get x value is equal to z. So previously we have x is equal to y. Now we have x is equal to 2y. Therefore we can write x is equal to 2y is equal to z. Why? X. 1 minute. Previously we have x is equal to y. This one. X is equal to y. Now here we have x is equal to 2z. Now combine all these. So 2z is equal to x is equal to y. Now from the equation xyz is equal to 32, we will use this condition. X is equal to y is equal to 2z. From this we will get z is equal to 2. Now substitute z is equal to 2 here. Then you will have x is equal to 4, y is equal to 4. Therefore the stationary point x comma y comma z is equal to x value 4, y value 4, z is equal to 2. So this is the critical point or our stationary point. If you want to find lambda value, previously we have two equations by making subject as lambda. By substituting these xyz values into any of the equation, you will get lambda value is equal to 1. So we are getting the stationary point x comma y comma z as 4 comma 4 comma 2 and lambda value as 1. By substituting these 4 comma 4 comma 2 into the given function, we can able to identify what is the surface area of the given function. Surface area of the given function at which the function will have minimum value. Means our aim is to identify the dimensions of the box, such that the volume of the box is equal to 32 cubic feet. See here, if you are finding, means if you are calculating from this point x, y, z, product of these three, you will get 32 cubic feet. So these are the values of x comma y comma z, and these values are the minimum values of x comma y comma z, which satisfies the volume of the rectangular box. So Till now, we studied about how to find the minimum value of the given function or maximum value of the given function by using Lagrange's form of undetermined multipliers. What is the procedure? Take the given function f of x comma y comma z or f of x comma y together with the constraint g of x comma y is equal to 0 or g of x comma y comma z is equal to 0. Form the Lagrangian function L of x comma y comma z comma lambda is equal to f of x comma y comma z minus lambda multiplied by g of x comma y comma z. This function is for 3 variables. If you want to write for 2 variables, L of x comma y comma lambda is equal to f of x comma y minus lambda multiplied by g of x comma y. After creating Lagrange's function, we will apply partial derivative with respect to x, y, z based on the number of independent variables availability. After equating these values to 0, you will have a system of equations. We will solve this system of equations with the help of g of x comma y is equal to 0. Based on that, you will get stationary points. By substituting these stationary points into the given function, based on the given question, we can decide either maximum value or minimum value. Now, these are the worksheet problems. Please try to solve all the model problems. Together with the questions I already provided, answers also. Please practice all these model problems. Thank you, one and all.
Like, share, comment, and subscribe VNR Digital Learning Resource YouTube channel.